Welcome students. In this video we will discuss how sound propagates. Now in the earlier video we have already discussed how sound is generated. Now in this video the sound will propagate and we will discuss how it does. Now for the propagation of sound it requires a medium, and propagation is done by the help of the particles of the medium. So whenever a sound source is excited, it starts vibrating, and this disturbance of this vibrating arm of this sound source also causes a disturbance in the neighboring medium. Now since the neighboring medium has some elastic property, it retains or it tries to retain its previous position or its previous state, that is its not excited state. So that's why what happens, the medium of the surrounding starts vibrating and the disturbance in the surrounding medium changes from two extreme points. In this case, what I have shown in this picture, the disturbance changes from an extreme density to an extreme high density to an extreme low density state. So whenever a sound source is excited, the neighboring medium gets excited, and with time this excitation or this disturbance causes a disturbance in the neighboring medium, and this disturbance propagates with time towards outer region. Now we can give you an example. Whenever you throw a stone in a pond, what happens? The portion where the stone touches the water surface, there the main disturbance is caused, and in the surrounding area a ripple is generated, and the point where the stone touches the water surface is the source, and from that source or from that point of excitation the ripples traverse towards the shore in every direction. And that's what also happens in case of sound. Here this tuning fork is the source, and these kind of disturbance transmit from this tuning fork and they go in all direction in 360-degree angle. Now this kind of disturbance has some unique property. In some places they are rarefied and in some places they are in high in density. Now if we draw the density profile or the pressure profile, because where there is a higher density the pressure will rise in this portion, but since there is a low in density of medium particle in this region, there will be a loss in pressure. So if we draw the density or the pressure profile of the surrounding medium with distance, what we will find? We will see that this kind of variation, and this variation can be with respect to distance or with respect to time. Now here we are drawing with respect to distance. Now what we see that in this region, since there is a lower in density and pressure, we are drawing the pressure profile like this, and since here is a higher pressure or higher density, so we are drawing it like this, and this portion is known as the crest and this portion is known as the trough. Now every sound wave that is generated by a source has some unique characteristics. The first characteristics is the time period. What is time period? A time period of a sound wave is the time required for the sound wave to complete a full oscillation. Now here the full oscillation may be from this. If we start, the full oscillation will be till that point where the sound wave repeats itself. So if we start from here, at this point the sound wave will repeat itself. So this distance in time domain will be time period. Since I have already said that this x-axis can be distance or time. So if we draw x-axis as time, then this distance will give us the time, and this time will be the time period. And other property is frequency. Frequency of a sound wave is the number of full oscillation completed by this sound wave in 1 second. Now there is another property of a sound wave which is known as the amplitude. Now amplitude is the maximum deviation of the particles of the medium from their mean position. So whenever a sound source gets excited or gets disturbed, the medium surrounding it also gets disturbed, and this causes a deviation of the particles of the medium from their mean position, and the maximum deviation of these particles is known as the amplitude of the sound wave. As I said earlier, what is the wavelength? It is the distance traversed by the wave while completing a full oscillation. So whenever a sound wave completes a full oscillation, if we look in time domain, that is, if this axis is time, then this distance will give us the time period. But if this axis is distance, then this will give the distance traversed by the sound wave in one full oscillation, and this will give us the wavelength of the sound. So wavelength is the distance traversed by the sound wave while completing a full oscillation. It is also can be defined as the distance between two crests or two troughs. And I said earlier, time period, it is the time required to complete a full oscillation. It is measured in second, and frequency is the number of full oscillation per unit time, that is per second, and the unit of it is hertz or cycle per second. That's all. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.